Hi, ladies and gentlemen. This is Mr. Green, and this is another in a series of recordings for Algebra 2. We're starting down our conic trail. We're going to start working with conics at this point, okay? Don't forget, you still got some study island work that's out there. You need to make certain that gets accomplished every week, too. Okay, due dates, things close up. We don't want to have zeros in the grade book. Get rid of those zeros. That's the main trick you got to do. So we're looking at circles today. Circles are the first shape in conics most people cover. Now, you might have seen this formula before, but you might not have known where this formula came from. Well, it comes from the distance formula. Because remember, a circle is all the points that are equal distance from a particular point. Well, if we use a point here and this distance here, that is our distance. We're going to maintain that distance all the way around to get the circle, right? That is the radius. So here's what I'm going to do. I'm going to show you how we're going to do this. We're going to use the distance formula. And if we start with a center at 0, 0 and a point out here of x, y, we can go the distance from x to 0, well, that's x minus 0 squared, plus the distance from y to 0, that's y minus 0 squared. And my radius at this one, in this particular one is 6. And so that's equal to 6. If I square both sides of this equation, I get x minus 0 squared plus y minus 0 squared equals 36. Well, minusing 0 is nothing. So x squared plus y squared equals 36. You can see I used the distance formula, and I got a formula for a circle. That's where that came from, was it was always maintaining that distance. If I had a point at 2, 5 and a radius of 3, I could do the same thing. Distance formula, x minus 2 squared plus y minus 5 squared equals 3 squared. Square both sides of this equation. I get x minus 2 squared plus y minus 5 squared equals 9. There's my formula right there. I want you to notice how we're getting the center. We're simply plugging the center in right here and right here. These are always negative signs if they're positive numbers, and they'll turn to positive signs if they're negative numbers for the center. So it becomes a real simple formula in which we can use. Examples. Okay, x minus 2 squared plus y minus 4 squared. Well, my center is going to be located at 2, comma, 4. How did I get that? Well, there's my 2, there's my 4. What's my radius? My radius is equal to 1, because the square root of 1 is 1. Let's do this next one here. My center in this one is going to be at 4, comma, negative 8. Oops, did you catch that negative 8? See the plus sign there? Made it a negative 8. My radius is going to be 8. Where'd the 8 come from? Square root of 64 right there. That's where I got my radius. Let's try another one here. My center on this one, negative 10, comma, negative 9, with a radius of 10. Now, are any of these hard to plot? Not at all. Let's take this last one, negative 10, negative 9. So I go negative 10, negative 9. My center is going to be right there, just barely on this graph at all. And with a radius of 10, there's 10 units going this way. There's 10 units going this way. My circle is going to look something like that. I mean, it's a very poor circle. And it's just the edge of the circle that's on that graph. Let's do the one before it. It's at 4. 1, 2, 3, 4. Negative 8. Well, that's 4. Negative 8 would be right down here. 4, negative 8. And it's got a radius of 8. That means there's a point there that'd be on it. Okay? And let's see here. It'd be a point 1, 2, 3, 4. Right there, that'd be on it. And a point just off the screen. Okay? So my circle is going to go something like that. Ta-da. All I'm doing is sketching them out. Okay? Let's see here. How about this one? 1, comma, 2 with a radius of 5. That one will be a little easier to graph. So I'm going to go over 1, up 2. There's my center. Radius of 5. I'm going to count 5 in every direction. 1, 2, 3, 4, 5. Over 5. 1, 2, 3, 4, 5. Down 5, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. And I've got my four. I got 4 points there. I can actually connect these together with a circle. And like I said, I can't draw circles with the mouse, but there it is. You can see how these are done. Okay. This next one, 0, comma, -4. How did I get that as the center? Well, there's nothing being subtracted from the x, so that's where I got the 0 from. And then it was +4 here, so that'd make it a -4. My radius, square root of 36, is 6. Last one here, be at 7, comma, -2. And my radius is going to be equal to the square root of 3. I didn't even look at that, okay? I can't take the square root of 3 and get a whole number, so I'm just going to write it down as the square root of 3. And that's all I'm going to have to worry about. Okay? Cool. Okay. If this was a test question, the center of the circle is at -2, 7. The radius is 36. Wow. What is the equation of the circle of the graphing form? In graphing form, well, you know what? I would write that as x minus a -2. So x plus 2, quantity squared, plus y minus a -7, so plus 7 squared, is equal to 36 squared. Well, coming over here, let's see here. Not going to be that one. That's got x minus 2. Okay. That one has a possibility x plus 2, x plus 7, but it's got a 6 for the radius. So I don't think the radius is correct on that one. So x minus 2, nope, that's not going to be that one. X plus 2, x plus 7, and then 1296. Wow. It didn't give me 36 squared. I have to do that one on my calculator. So 36 squared is 1296. So that would be the correct answer in that situation. See how I eliminated those individually? Okay? Going forward. Which is the graph of this one? Well, look at my center. My center is going to be at 0, comma, -3. My radius is going to be 3. Well, I'm looking at these, let's see here, going over 0, down 3. That one works. Radius of 3, 1, 2, radius of 3. That one is actually the correct one. The first one I looked at. How do you know? Okay? Is it going to be C here? 0 minus 3. That's not the center here. So it's not going to be that one. Okay, 0, 3, 1, 2, 3, be right there. Nope, it's not going to be that one. And 0, 0, 3. Nope, it's not going to be that one. So I mean, all three of those got eliminated because the center is not in the right location. Okay? The equation of a circle is at x plus 10 squared, y minus 4 squared equals 100. What is the center and the radius? The center is going to be at -10, comma 4, and the radius is going to be 10. Square root of 100 is 10. So let's see here. That's got a wrong radius. That's got a wrong radius. Let's see that right away. That center is not in the right location. There's the correct answer right there. Cool. Okay. 2 more questions quickly here. It says, the blueprints for a police station show that one of the lamp... Oh, man. Can't read it, too small. One of the lamp posts has a motion detector on it. And the equation x plus 14 squared plus y minus 6 squared equals 9 describes the boundary within which the motion can be sensed. What is the greatest distance in feet a person could be from the lamp and be detected? Well, that's going to be the radius. So all I got to do is look at this radius here. That's 9. Square root of 9 is 3. And so the greatest distance it could be away, 3 feet. A homeowner plots her house and yard on a computer. She determines that the circle that defines the part of the front yard that gets watered by the sprinkler is x minus 9 squared plus y plus 11 squared equals 16. What is the diameter in meters of the circle that gets watered by the sprinkler? Well, that's real simple. My radius is equal to 16, or square root of 16, right? Which is 4. And my diameter is going to be equal to 2 times 4, which is 8. So it's going to be 8 meters. Okay, moving on. This slide has everything you need to know for circles. See how it's got the distance formula down here? It's got the formula for circles on it down here. So what I would suggest doing is making certain that you save this slide. Get a picture of this somehow, okay? And save it, okay? When I do Class Connects, you will have this up on the screen. You will be able to save it from there if you need it otherwise too, okay? So this is showing you how things are symmetrical. It's also showing you the different conic sections that we're going to be talking about. It's showing you the distance, the midpoint formula, and the formula for circles. Okay, well that's all I've got for today about circles. I do appreciate you guys telling me that you're in Algebra 2 when you send me notes and messages. I look forward to seeing you in Class Connect and in tutoring sessions if you have questions. I will talk to you next time.